Good afternoon, everyone. I think that many of you are familiar with the basic concepts of data fusion, where we're trying to find some linkage between different data sets based on common fields or variables or values to merge them together and build a new data set, a single data set that carries all the information and knowledge of from various sources. Today I want to talk about anonymous data fusion, which is a new data fusion techniques that allow us for merging different anonymized data sets that are not that we are not able to merge them together with traditional data fusion because there is no common field or variable there. Nowadays, we are leaving digital traces in our everyday life through interacting with our environment. And in the era of Internet of Things and Internet of Human and Things, humans are interacting with other human and things, and also things are interacting with each other. Consider a case of a smart city that uses smart cars in their infrastructure and for transporting people. All these cars has a lot of sensors implemented inside, and they are trying to sense their environment and gathering knowledge from all the activities that they are happening around them. And then they are communicating this knowledge based on their sensors to other cars and city infrastructure, traffic lights, and so on and so forth to make a decision about which direction they need to go. Should they stop or should they let the other car take over? But apart from this smart cities and smart cars that is more futuristic but not for a far future, we are leaving digital traces in our everyday life through wearables. We are recording all our vital sign and all of our sport activities with smartwatches like Fitbit or Apple Watch and different wearables. When we are making a purchase, so we are leaving digital traces that record where we are shopping, what we are shopping, and when we are shopping. All this information is recorded by using credit cards and debit cards. When we are taking a public transportation, all this smart card that we are using keep track of where people are tap in and tap out, and so the trajectory and the trips that people are taking. When we are even taking a taxi, all the pickup, drop-off location and time is recorded, and not to mention the Uber and Lyft that all the platform is online and all the trip and all your interaction is recorded. But above all is smartphones that we are using. From when we are making a call or writing a text or using internet, all this interaction of this phone with their cell towers are recorded by telecommunication companies, although they are only metadata, not what you are talking on your phone sometimes. But it's essentially the communication, the events that are happening there. When we are using social media, and we are using geo-tagged posts in Instagram, Facebook, Twitter, and all of them are creating some traces, digital traces of us in the real world. Very simplistic applications and various applications in our smartphone, like weather apps. Have you ever asked why there's so many weather apps with the same functionality, but with the same source of weather reporting that they are available to download for free? So the main functionality of these apps are keeping track of people, not reporting the weather. The weather is the service that give you actually the cost that they pay to get your information about how you are moving and how you are actually sometimes interacting with your environment. But all these data sets tell us one side of a story, and the story of human life. So if we want to use one of these data sets to build predictive models or recommendation systems, our knowledge and our model are contained to the limit of one data set and cannot be as impactful as it should be based on the knowledge of, based on what we can get from the customers and the people, the service that we are providing. For example, based on the movie ratings, one can suggest a movie to one person and make sure that that person loves that movie based on all the historical rating and other people rating these recommendation systems. And they can make sure that that people loves the movie. But is that person in the mood to watch that movie? Is it the right moment to suggest this incredible movie to this person? Probably this person is, in general, love the drama movies, but now she wants something that cheers her up, not something that turns her down. But if you have other data sets like social media there that we can find out the emotion and the situation of one person. So with combining these two data sets together, we can build some more powerful and insightful platform to address many needs and services. But what are the challenges in merging these data sets and making a data fusion? The first thing is finding the relevant data sets. So I have a question in my mind I want to answer, and I have a specific data set that I acquired or I have access to it. But what are the other data sets that I can merge to this data set and expand my knowledge with that? So this is more and more, this is a crucial question, but it's more and more become less of a problem with the availability of the data. So many of the data become public, and many city governments, for example, they are making all the information that they are gathering openly available for the public, and some companies are partially available, make available their data that they have. But another problem that we are facing, or a challenge, is anonymization. So anonymization is essential to protect people's privacy. But with simple de-anonymization techniques like a hashing identifier, replacing it with a random number, or adding noise to location or time of the events that they are happening, to more complicated, more complex anonymization techniques like k anonymity that make sure that at each class there is at least k individuals sharing the same thing to differential privacy. But at the end, making sure that the privacy is not getting violated and making everything anonymized has a trade-off with utility. If you want to make sure that the data is fully secured and is anonymized, we should not do anything with it. We should keep it in a safe box and don't let anybody touch it. But we need to use the data. So data is there for using it. Otherwise, we were not collecting it at all. So we cannot fully anonymize it, fully protect the privacy, and we cannot make it available there for any use that people want to do. But although we care about the privacy of people and individual, nobody cares about the privacy of the environment that people are interacting with. So, for example, we don't know who is taking a taxi in front of Prudential Center, but we know that someone has taken a taxi in front of Prudential Center. So these locations are there, the environment, the city that people are interacting with is there. And this allows for many of uses that we can have with many data sets, although they are anonymized. But this is not enough for merging two anonymized data sets together. But what we need and what we are taking advantage of is patterns in each data set. So people behaviors there is a lot of regularity in people behavior. In one study with a Spanish bank, a leading bank, we analyzed data of Spain, all over Spain, which is, you can see this is all credit card transactions that are happening during Easter week there. So the blue is grocery store, yellow is gas station, pink is fashion, and red is bar and restaurant expenditure. You can see there is a clear trend of when people are going for lunch, when they are going for dinner, and how they are spending the regularity during the day. But when it's reached the Friday, which is a holiday, the trends is different. So people, because all the grocery stores are closed, nobody is spending anything there, but people are spending more in bar and restaurants. And the day after, when the grocery stores are open, there's a rush to grocery stores, and you can see that people, because they are out of food, now they are going to grocery stores more. And then after the holidays, it goes back to the normal and the same patterns that people are doing it. This is an example of a credit card transaction. And you see lots of regularity and patterns in what people are purchasing and how people are doing in a specific times and specific events. The same is for many different data sets. Here an example of telecommunication data, the call and text that people are making, but the time that they are making the call. So it's here you see that the calls, the red one over there is the call that is made in the New York, Manhattan, a financial district. And the blue one is a neighborhood, a residential neighborhood in Brooklyn. You can see that there is a clear difference between these two neighborhoods, if it's financial or if it's residential. And you can see all any of these peaks is for 1 day, and you can see the data is for 1 week. During the working days, there is a clear similarity between every day, and Saturday and Sunday are very different than the rest. So by only look at these trends and without having any prior knowledge, we can identify that, okay, this is the calls that are being made from a residential area or from a financial area. So there is lots of information from the patterns that people have in their everyday life. And this is the foundation for anonymous data fusion. So let's hear the other side of the stories. I start with one example of call letter records that I showed there. So basically, consider a very simplistic world that 5 coworkers go from their work to their home, and they are making call along the way. But what the telephone companies record is not exact location. It's something like this. This is the coverage of a cell tower. And when they are moving, the cell tower is changed. So they have approximate information about where they are making calls. And this is a trajectory that telecommunication records, call detail records, you can see it. But with this one, you cannot distinguish these people. If you have only this information there, because they are making calls, so their resolution is very coarse, so you cannot distinguish these people from each other. So the privacy is protected. Although all this information, all these individual trajectories are anonymized, de-identified. So I don't know who is who, but if I have information from other part of the city that they have made a call, so now I can single out one trajectory. Although it's anonymized, I don't know who is it. It's a random people that random ID that I have taken out. But with this information, these are simplistic examples. So if I have these two information, I can single out this trajectory and look at this trajectory to see what are the patterns in these trajectories and build some metadata based on this pattern that I can get. And the same for other individuals. And it has been shown that for real data sets with only 4 random points, 95% of trajectories are distinguishable. This has been shown for call detail records, for credit cards data, although they are anonymized. Even you see here, the resolution is very low. In some cases, tens of meters, or in rural area is many kilometers. But still, with 4 random points, we can distinguish these traces. And this is another important thing in anonymous data fusion, that we can distinguish traces, build some pattern, find the patterns in these traces, and do the same thing with other data set, find the individual trajectory, build the metadata based on the patterns, and try to merge this pattern instead. So these patterns are something that was not available in any of the columns of data, something that is built upon the individual behaviors. And one example would be this merging call detail records with public transportation that we are doing. This is where people are tap in and tap out. So the public transportation is very sparse data set, because you have, for each trip, you have only 2 points. But when we merge these 2 data sets, it has a lot of value for public transportation management. Because now what the way that they are managing their demand is based on the statistics that they have. They know that, for example, when is the rush hour, they need to increase the supply. When is the people are not taking when people are not taking the public transportation, and many things based on historic data that they have. But if something happened in the city, like there's an event that they don't know how to react to this event, is it a big event or not. So by merging these data sets, the call detail record data is a very detailed and real-time data set. So if we have the knowledge from if we merge the knowledge from call detail records to public transportation data, so we would be able to predict that, for example, in 1 hour at this station, we will have thousands of people coming. So we can plan ahead. So it generates new insights. And these insights, I will give you 2 more examples of how it can help to provide better services. For example, retailers are very interested in knowing the customer's experience. And when you are in their retailer store, in-store, they know everything about their customers, from the inventory that they have, how many of one product they have sold, to the loyalty card that they give the people, so they keep track of what you have purchased, at what time, is there any pattern that you are doing it monthly or yearly, to using some sensors in the aisles, so they know that, for example, some people are spending time in front of one shelf, but purchasing nothing. So what's going on here? Is it the price is too high? Is the product is not interesting? So there's lots of information they can gather from their customer experience in their store. But when the customers get out of the store, they lose track of them. They don't know anything about them. Is there any product that their customer are interested in but they don't offer, so they cannot, they don't have any mean of knowing it with their the in-store sensors or loyalty cards? Or is there any particular thing that their customer bring their customer to other retails and they are losing their customer because of that? But if you have some sort of location proxy, like the phone call records that I said, or simply the credit card transaction that you are purchasing in other places. You are going to gym, so you know that these other people are interested in sports, so which kind of sports? Are they going to events? Or the social media that publicly available, they are posting about their interests, they are posting about where they are going to, when they are going to bar and restaurants and using wireless networks. All these wireless networks keep track of the people, I mean, the anonymized version of people, the MAC ID of their devices, how they are moving, and you can get some more knowledge about where they are spending time. And by this means, you can have a broad knowledge of the customers, that what they are interested in, and what are they interested in going to cinema, going to watching a sport event, or many other things that you cannot, many information that you cannot get from in-store experience. Both these data sets that I mentioned are all proprietary data sets. Nobody can have access to credit card data and phone call records. And many of these companies, they are not sharing their data because it's an asset for them, and they don't want to share with their competitors. But I want to give you an example of publicly available data set. Taxi trips in New York, which has been publicly available for many years, and everybody can download it. So we visualized it, all these pickup and drop-off locations. Here you can see the yellow is pickup, the blue is drop-off location. And this is the map of New York. You can see immediately there is a supply imbalance. In New York, you can easily take a cab, but in Brooklyn, you will have hard time find a cab because they are somewhere else, and it's actually a very well-known thing that you cannot easily take a cab in Brooklyn. And if you go to JFK Airport, you can see that there is the cabs are queued for passengers to come. So with only visualizing this data, this publicly available data, you can see this imbalance, and probably you can do something for it or not. But this data, we can look at it at different scales. A very aggregated one that gives us lots of knowledge to a very individual one. You can see this data, that this visualization was based on these points, this pickup and drop-off points, and this was only zoom out to see some aggregation there. But using this individual at a very fine grain scale, we can do something more. We can. This is a project that's in our lab that about ride sharing, how we can share a taxi ride between different passengers. That was initiation for Uber Pool and other products. So this is about how we can build these networks based on this data that we have and to examine the shareability of networks. Here's an example of, again, purely based on those publicly available data of taxis. This is a hubcap project. So there's a website. You can go there and pick up and drop off location. It can tell you how many trips is going from this location to other location yearly. And interestingly, this one is a 1 block in Manhattan. And 23,000 rides between only 1 block is happening. That is, it's insane, but it's ridiculously shareable because the people are going exact direction and very short distances. But from this one to very more complex trajectories, we are able to build some networks that if the people allow for some inconvenience in time, so we will have, we can make the taxi trips shareable. You can see here, if you allow for like at most 5 minutes, so all the taxi trips in New York are shareable, all of them. And these two plots is, one is when you, the Oracle one, the upper one is about when you know everything about these trips, so it's not predicting, it's we have the data, we know where people are going now, try to match and share their rights. But the other one is the online model, that we want to know, this is like what Uber Pool and Lyftline is doing, to put people into the one cab and share the ride. So if we know everything, so it would be great. So with only 50-second inconvenience, we can get 80% shareability. But even in the case of the online model, after 2 minutes, we can have 2.5 minutes, we can have 80% of the rides shareable. Okay, this is an example of a data set that we can do many things at different levels, at different scales, individual scale, aggregated scales. But still, this is limited. What if we merge this data set with other data sets, like public transportation data sets? So when we merge this data set together, because the problem is both of them are anonymized, you cannot simply put them and join them. But based on the patterns in the data set, if we are able to do this, so we know that at which station people, the customers of public transportation, when they are leaving the station, they are taking a cab. So this means an inefficiency in the public transportation. So we have the knowledge from different mode of transportation, and we can try to optimize this mode of transportation together to better serve the transportation of people in the city, or merging with other transportation like Lyft and Uber that now in many places there are not, you cannot easily find Lyft and Uber, and you can see if you can find taxi or not, and trying to sort out this supply imbalance and generate a comprehensive solution for transportation. Okay, having said that, data fusion is obviously can raise many privacy issues and generate new threats to the data sets that they are fully anonymized before, and now they can easily de-identify by having another data set that is not anonymized. So there's, if both data sets are anonymized, so we are merging them, no problem. But if one of them has identifiable, when we are merging them, we can de-identify the trajectories from them. And continuing with the taxi example that have pickup drop-off location and the time of this pickup drop-off location and many other metadata that they have added to this data set. One work has done to de-identify the celebrities' trips. So there are many photos of celebrities that taken in New York with the exact timestamp and location. So if you know exact location and exact time, you can easily go to this taxi data set and find out who was the person that taken the cab at that location. And it's only Bradley Cooper. And you can find the trajectory and find the drop-off location. And even if you know the drop-off location, because it's very exact location, exact time, you can find out the pickup location and other information, sometimes like how much they have paid, how much tip they have given. So this is nothing new. This is not about the anonymous data fusion. This is simply about data fusion, that one data set is not anonymized. But in the case of taxi data, it was not properly anonymized, although all the identifiers are removed. But the location and time was exact. So if I search for one specific time and location, I will find one person, one cab that you are taking to it. So if you see someone is taking a cab, you can go to data and find out where this person goes. So this is a real problem. But with the anonymization technique that I mentioned, like k-anonymity or differential privacy, we are avoiding all of this. And this way of de-anonymizing people are not possible. And this is because it's where you don't have the exact location, everything is noisy, you don't have the exact values to merge. But still, the anonymous data fusion can work there. And this is not specific to taxi data. All the social media that we are using, the Twitter, Instagram, and all this information that we are publicly make available there, it can be a proxy for de-identifying all information about us. Some people have this anonymized, but they can find out more information about us from the publicly available data set that we have. And one example of such works, again, with traditional data fusion, not with the anonymous data fusion, is when they are de-identified the healthcare record of government of Massachusetts based on the publicly available data of health and the voter data that was available. But again, this urges a new set of data protection and data anonymization. Although this can have a lot of application and making the knowledge that we can get from different data sets very comprehensive, but there are many privacy issues. We cannot anonymize one data set only based on one data set. So we need to consider other parameters, and this is a growing field of anonymizing data based on a collective knowledge that they can provide. So this anonymous data fusion is going to be a platform that people can share the information anonymously, and no one has access to other data sets, but they can ask some specific queries, and these queries cannot be they have some limits on these queries, because if you ask any question that you want, you can de-anonymize the other data sets. So this is about fusing, because the third party that gather all this information is still anonymized, but with this way of data fusion, they can fuse the data anonymously and create a collective knowledge that can address many informed decision makings without compromising people's privacy. Thank you. Any question? Yeah.
So are you familiar with, and what are your thoughts on this document about de-identifying privacy data sets for government stuff as applied towards personal data sets? Is it something that you're familiar with and you find to be useful or educational?
Is it documentary or something?
From Garfinkel together with this document.
I am not familiar with that one, yeah. But. Yeah.
So apart from sensor data, are there any initiatives to collaborate with other applications to get customer data like mobile apps and stuff? So in terms of analyzing or using data, apart from sensor data, there are lots of mobile apps which also have data repositories and make it anonymized. So in terms of grocery, if you can
Mm-hmm.
look up
Yeah.
projects on those.
Yeah, so there are lots of applications that keeping track of many things that's happening surrounded you. Even when you are going to grocery store, for a simple example, if you are taking out your mobile and check with Amazon the price, so it might be able to record the location, what was the product, and give information from what you are purchasing from other store, even if they don't have that product in their store. So there's lots of applications that essentially use the location services, and if you see them, many of them ask for using your location services, even if you are not using the app. So because these location services are very valuable, and you can infer a lot of things out of it. It's not only locations, because locations has meaning. If you are in a grocery store, you are purchasing something. If you are at a stadium, so it means that at a specific time, it means that you are a fan of a specific team. So there's lots of information attached to these locations, and that's why the enabling or not enabling the location services essentially can dysfunctional one app the purpose that they want. Yep.
Have you considered using a variable that talks about whether or not the data itself had information that you had to strip as a predictor variable in your model for fusion? Because I'm mindful of the fact that there are different levels of information, right? The proxy information on the one hand is at a larger level. The information that you removed is at the more personal level, and that could create a stronger signal for creating fusion models that are better.
So the question is, there are some information that we are removing, but we can use that information for fusion model?
You used the fact that you had information that you had to remove. Right? So the binary indicator that says this data came with personal information, other data didn't. And so that means that that level of information is probably at a higher level than the information that you removed. That signal could be stronger for that piece of information, but you lose it in the fusion models if you don't include something like that.
Mm-hmm. Yeah. The thing is that when we have two different data sets, we know mostly how they are acquired and what are they about. So even without having this flag that something is removed or not, so essentially something is removed, because otherwise we had information about what is this person that is doing these specific things. Or at another level, it doesn't need to be exactly individual level. If it's like household level or city level, that many things can be removed, but not city, because there is no people's privacy there, but at different levels of group of people. But I'm not sure having know that this is removed or not, this data contains some identifiable or not, would benefit the fusion model. Because what we are doing here is, again, try to find what are the patterns. It's helped a lot that we know what is this data about, what is specific patterns that we need to look for. But I'm not sure that it would help if we know that something is removed or not. Yeah.
Quantify the uncertainty or the amount of information we get out of the different models to combine them?
What?
I can combine that person is the same because of the probability like efficacy information.
What we are doing is defining a matchability score. So try to find out without doing the fusion, before doing the fusion. Try to find based on the patterns, it's somehow a dry run over all the data set, and try to find out how much these data sets are matchable. So if we have enough information based on the distribution that they have, based on the overlap this data have with each other. So we try to find out this matchability score, and then we can see that this data is protected against other data set or can easily be identified with other data set. For last question, if there is any. All right, thank you.